Hi there. Okay, so for part 2 of the reaction table problem, we're asked to write the balanced equation for the overall reaction. So, step 1, we see that NO2 decomposes into nitrogen gas and oxygen. And then in step 2, oxygen and NO2 combine to form nitrogen gas and oxygen gas. So how we write the balanced equation for the overall reaction, we basically just cancel out anything that repeats on both sides and add anything that's there. So what we get is we've got N2O here on this side, N2O here. They're both on the reactant side. So we end up with 2 N2O. And then we've got 2 N2s and 1 O2. That would be the balanced equation for the overall reaction. You can see that's 4 nitrogens, 2 oxygens, 2 oxygens. Part G asks us, is the oxygen atom O a catalyst for the reaction, or is it an intermediate? Now, if you notice, we actually canceled O here and here, because in step 1, O is seen as a product, and in step 2, O is seen as a reactant. What this means is that O is consumed. And O is consumed because we canceled it out, but it was used to make the nitrogen gas and the oxygen gas. So, if O is a catalyst in the reaction, it actually would not be seen at all in the reaction mechanism. And that's how we know that it's an intermediate, because it is seen and it is consumed. Now, part H, we're asked to identify the slower step in the mechanism if the rate law is determined to be KNO2. Okay, so the rate law is actually equal to the rate constant times the concentration of reactants. And actually, in step 1, the concentration of our reactants, our reactants are NO2. And so that's how we know that step 1 is the slow step, because the slow step is the rate determining step, and if our rate is K times N2O, then where we look for N2O, that's how we know that step 1 is the slow step. We know that step 2 isn't the slow step because O would be included in the rate law, and O is not included in the rate law. Hope this helped.